Welcome back, Trig fans. We're going to look at trig limits and derivatives, part 2. So we're going to look at trig limits, part 2, and we are moving toward being able to prove the derivative of sine and cosine and tan and other things so that we can consider angular velocity. So here we go. So today we're going to skip through this incredible proof by Jasper Calder, mainly because you don't know what the derivatives are yet. So come back to this if you're interested on another way of thinking about this proof. But for now, we're going to kind of sneak ahead here to the first challenge. And here it is. So once again, in order to be successful with trig limits, you need to know that. You need to know that as x goes to 0, sine x by x equals 1. You need to know your sine wave and cosine wave, and you also need to know your trig identities. A formula sheet will be provided. All right. So at first glance here, we did this one very similar to this in the last lesson. You're basically going to want to multiply top and bottom by 1 plus cos x. So you'll notice that there's not a ton of support here, and that's your first move. Okay, so multiply top and bottom by cos x, use the Pythagorean identities, and go from there. Let's look at this one. This is a bit harder. Okay, so make sure you're trying this before you listen to my voice. And here we go. So first things first, we're going to panic on this one probably a little bit. Notice that the first move here, we might turn this to using the double angle identity, sine 2x equals 2 sine x cos x. Then what we're going to do is factor out a 2 sine x. There's some great moves in here already. Look, I can take x equals to 0. Hopefully I did that. I'm going to choose and be strategic right now. I'm going to put 0 in for x now. The cosine of 0 is 1. The cosine of 0 right here is 1. So basically you're going to have, on this side here, this piece here goes to 1, and this piece here is going to be 1 plus 2 times 2, if you can see that. Okay, so when we look at the graph of that, which we should, just to round out our understanding here, as x goes to 0, we can see that this thing is getting pretty close to we can see that that's pretty hard to see. But we can see that that's getting pretty close to 1/4, which we can see there, and that's what it is. Okay, so note that. Here's number 3. So try this question and then listen to my solution if you find it helpful. So first things first on this, probably going to use the double angle identity here and probably going to factor out the top. So that's exactly what we're going to do here. We're going to multiply top and bottom by 2 and 2, because notice we already have the x squared there. And when we do that, I'm just going to rearrange this. So I'm going to have the x squared combined with these two guys for 2x over the sine 2x sine 2x. As x goes to 0, cancel. Now I just have, as x goes to 0, I'm going to have 1 over 4, which is -4. Let's take a peek at this guy. I'm kind of feeling a little bit of trig identities here, maybe a little bit. So let's see what we're going to try here. Oh, I guess that's all we're going to get. So we are going... Okay, I'm back. So let's see how's this one going. So we are going... Oh, I didn't give you much here at all. So you're on your own here, but just looking at this, I would make that 1 over cos. And we know that as x goes to 0, that's going to turn into 1. We're also going to have 2 sine x minus sine x over cos x. Look, the cos x on the bottom is going to go to 1 again, so you're really going to have 2 sine x minus sine x. So you're going to have sine x over x, and that's why this thing goes to 1. I know that for most of us, that probably wasn't what you were hoping for an explanation, but I really want you to wrestle with that. What we're going to do is use the reciprocal identity here, reciprocal identity there, let cos x go to 0, and that's going to go to 1, which we know. And okay, here's the last one for our second lesson. So first things first, let's use our double angle identity there, and I didn't show you that. So you're going to choose one. Which one makes most sense to use? Probably one with sine in it, partially because 1 minus sine is 0. So you want to use that one and then take it from there. So use your trig identity right there and then simplify as you need to. So these explanations are a little on the shorter side, but hopefully they're at least getting you moving in the right direction. Please come and see us if you need anything. And these would be great questions in your textbook to look at. Really strongly recommend those questions. Most people find trig limits very hard, make lots of mistakes. It's a huge thing that people need to retest. So make sure that you're putting your best foot forward on that. And I think we'll end the video here.